Guys, I've been inspired, well, probably more accurately shamed, into finally getting this float lock vise working. I'm sure most of you have seen the series by Mark Persling, aka Prozo. I'll put a link below to his series where he built a float lock vise. Did a fantastic job. So I picked up this vise a couple years ago at a machine shop sale. Got a good deal on it, but it's got a couple issues, mainly here with the clamping block, and it's just been sitting here waiting for me to do something with it. So it's finally time. Let me zoom you in and we'll show you what's going on. Now, I did not get the anchor block or bracket that goes with the clamp block here. I don't know what it had on there originally. It may have just been bolted through the table of the drill press, who knows. But here's the first issue. Our threads on the draw bolt are completely knackered. So I'm guessing somebody either made or just found this spacer, stuck it on there, so they could use what was left of the threads on the end to clamp it. Okay, so we're going to get rid of that. Now this little draw bolt here. So fine thread on this end, coarse thread on this end. And it's got this barrel in the center here, which, you know, matches up nicely with the bore on the clamps. Okay. Handle is fine, just needs a little bit of cleaning. All right. Little handheld here. It looks like we've got enough clearance that we'll get a good clamping effect on the main bar here. If not, we could just take a little bit off of here. And I think if we get all this dirt off of here, that'll help it also made up a little better. Okay, let's look at our options for the anchoring block. The quickest and easiest thing to do on this type of table is just use a T-nut. This is a 1/2 inch T-nut, and it's the same as the Bridgeport, which makes it convenient. So we could put in a T-nut, go right over the top, put our bolt in, boom, Bob's your uncle, right? But we would lose a lot of range of motion doing that. The other option would be to bring this out to the outside edge. These surfaces are the same plane. Just drill a hole through this drainage channel and put a longer clamping bolt. And you know what? That actually probably wouldn't be that bad. Not a lot of surface area over here, but it would probably work. Okay. All right. But what I want to do is move this off to the side. Okay. Create some type of an anchor block that goes out here. You know, that will give us essentially the full range of the table. All right, let me show you what I'm scheming on. So in my scrap pile, I had this cast iron pillow block, and it was completely rusted. I had to give it the vinegar bath soak for several days to get all the rust off. So I'm thinking I could modify this block, and this is going to be the hard part, is matching the radius of the table here, especially since it would be concave. That's not that easy to do. You know, I think that would be a good solution if I could figure out a way to get that attached to the table at the same elevation as everything. That would work out nicely. So let's go over to the bench and have a look at this thing and talk about a couple issues. Okay, first thing, it looks like, this is our clamping side, looks like we've got plenty of surface area here to work with. So the size of the block is good, or good enough, I guess. But this block has draft on it. Can you guys see that? So we got a draft angle here. There's draft angle on both sides. Yeah, so we've got that to deal with. The other thing Mark mentioned and showed in his build is that this anchor clamping block is not milled 90 degrees to the main drawbar here. Okay, it's got a slight, I think he said it was a 1 degree angle downward, so that the vise pushes itself down against the table when you clamp it. Okay, so I checked that, and hopefully you guys can see that it is slightly angled. If I turn this block around the other way, now you can see it's going slightly downhill the other direction. Okay, so that's good. So that angle is built into this block. That makes it easier for the one that we're building. We can just keep everything flat and at 90 degrees and parallel to our tabletop. I'm going to go over to the belt sander and just see if I can flatten this a little bit, get some of these dingleberries flattened out. That ought to be good enough to get it to clamp in the vise. Still a little concaved here in the center, which, yeah, and that may work to our advantage. So I've got a little spacer rod I'm using, like a parallel, under this side of the block, and then we got a piece of soft aluminum wire against this jaw, and I've tapped this down, so I think it's going to work. So let's see what happens. Switched over to a carbide cutter, much better results. Well, that cleaned up pretty good, but I don't know if you can see it. It's still got a little bit of a weird effect here. I think it's this radius is doing something to the tool bit when it's coming across. And we got a little tiny spot here that didn't clean up. So I'm going to take one more pass, so light pass, maybe 5,000, see if we can take care of that. Fingers crossed. It looks like this is going to be a good finished pass. Well, that took some time, but man, I love that finish. Yeah, I think I'll go ahead and clean up this side, get it parallel, get these two sides parallel and somewhat square to the bottom here before we move to the next step. I've been trying to work out how I'm going to cut this radius. It's not the easiest thing to do. If we had a CNC mill or a CNC router, probably be a whole lot easier. But let me take you over to the floor and I'll show you what I'm scheming on. Alright, I got the big 12-inch rotary table, which is not going to be any fun lifting up onto the mill. I'll probably bring the hoist in to do that. So here's my idea. I might be totally out to lunch on this, but hopefully this will work. So I've got a scrap piece of aluminum here, and I've already laid out a couple holes for hold down bolts. So we'll just put in a couple T-nuts and some studs to bolt this plate down to the rotary table. Drill a 1/2-inch hole, and on the center of our rotary table I've got several adapters in here. Well, that one's stuck right now with a Morse taper 4, it's a Morse taper 2, and then this is a Morse taper 2 end mill holder, 1/2-inch end mill holder, and then I just got a yeah, we'll leave that in there for now. I just got a piece of 1/2-inch rod in there, okay? So that will get this plate centered, or keep it centered for our layout. So then I measured from our center to our radius, and now I'll be able to mark out where I need to put a mounting hole to bolt this down to keep everything in line. Well, this ought to get the comment section going. Would it be a total redneck move if I used a piece of wood instead of sacrificing this nice piece of aluminum? I mean, it's nice and thick, it's pretty stable, it's flat. Let's try it. Continuing with the episode of Bubba Makes a Wooden Fixture Plate, I've got a 1/2 inch brad point drill bit in a collet, and I was going to try, I did a pilot hole, and then I was going to try going through with an end mill, but then I just went ahead and tried the 1/2 inch brad point, and it made a beautiful hole. So it's got a real good fit. So I'm just going to go for it. That actually worked really good. Those holes came out nice. And then on the back side, you can see I put a Forstner bit in there. Had to do a little counter bore for that one. That's the center of the rotary table. All right, let's go see how it fits on the table. Oh, that fits really nice. Yeah. That might actually work. Off camera, I got our rotary table bolted down, squared up, and zeroed into the spindle. I'm here, but I got room for the end mill to get past, so. Okay, I got a problem with our redneck engineering. So either this board isn't completely flat, although it looked really flat, even though it's pretty crusty. So I think the easiest thing to do is just to shim this. Well, that's out by quite a bit. Okay. All right, let me see what I can do. I'll bring it back. All right, so it took quite a few adjustments, but I think I'm going to call this good. All right. I just used our template and a little bit of spray paint for our witness mark.
So we touch off.
We're hitting mostly in the middle and a little bit down at the bottom. And we're using a carbide rougher. I may slow the speed down a little bit, because we got to get through this this hard surface layer, this cast iron. It's cutting better as we get through that hard layer, so should get better and better as we go. Taking 10 thousandths per pass. Almost there. I'm going to leave a slight remnant of that line, so maybe 2 more passes and we'll be there. Before I completely break down this whole setup, I'm going to take this block out, take it over to the drill press and see how it fits. Because we can always put it back in here if we have to fine tune it. So we got a good fit on the radius. I'm going to come in here with a straight edge and make sure it's flat. But we got a tiny bit of rock. See that? So what I noticed is that end mill must have a worn spot kind of in the center. So I'm going to swap out that end mill and just do a quick skim pass and see if we can clean that up. Okay, that cleaned up nicely with just a light skim pass with just a standard end mill. Okay, so let's see how that's going to look now. Okay, there's no rock. Much better. Yeah, I think we're good. I'm making this up as we go. We've got to drill a clearance hole for our attaching bolt, and that needs to be perpendicular to the radius where we go through. Okay, so I got a block of aluminum or aluminium, and if I hold back 1/8 of an inch from the end, I've got a good fit on the radius. And we're flat on the bottom here because this will be in the vise. So that should work out good. We can drill our clearance hole, and we can also face this top so that it's at the same angle as our bolt. We're back to our carbide cutter, and I slowed the speed down. We're in back gear. I just stopped to double check everything. We're getting a funny pattern here because of the pattern draft that's in our part. And I also transferred our layout line to this piece of masking tape because we're going to lose that line, or it's going to be almost impossible to spot it once we get down a little more. Probably take another 40 or 50 thousandths. We're getting kind of close to our vice jaw, so we'll just be careful and keep an eye on it. Okay, that gives us enough clearance for our bolt head. I think we're going to leave it at that. Okay, let me get set up for drilling. I made an engineering decision to move our hole location over a little bit, about 1/8 of an inch actually. That gives it a little more clearance if we ever need to put a washer on there, and it kind of looks a little better, so we're not crowding the inside. All right, let's go ahead. Okay, I'm happy the way that came out. Looks pretty good. So now we've got to transfer punch our hole locations on the drill press table, drill them, tap them, and we've still got to make a new anchor stud. Okay, I got it where I want it, and we're lined up flat with the table. Looking good. I'm just going to come in and transfer punch, drill and tap. I'm going to do that off camera. Poor man's drill guide. Just sawed off a 3/8 bolt. Well, first I drilled it out in the lathe to match my pilot hole, pilot bit size. I think that'll work. We're going to give the old South Bend some love. Yeah, this is easier on this machine because it's got to call it. .501. We're 1,000th over. Okay, I like it. We've switched to the Enco. This is my first time threading on the Enco, and I gotta tell you, it's not as user-friendly as the South Bend. The threading dial, I do not like it. It runs way too fast. And the half nut, the South Bend is smooth as silk when you're engaging and disengaging the half nut. This thing is more like shifting a Model T Ford. So I've been doing a bunch of practice runs here, just cutting air, just to get used to the feel of everything. Okay, I'm probably going to do most of this off camera, so I can keep my concentration. Let's do the first. Okay, second time, much better. So it's still just a tiny bit tight. So I think I'm just going to run a die on there. Just do a little final cleanup. Yeah, so this lathe, I mentioned before, the half nut is really rough. I mean, you've really got to be on your toes to get it to engage correctly, and it's really easy to miss, okay? Hopefully I'll get more comfortable with that as time goes on. Anyways, got through it. Maybe I'll try to film the next one, we'll see, okay? All right, let's continue on. already checked it with the nut, but let's try our handle. Make sure that's going to screw on okay. All right, I gave everything a modest cleaning. Our stud came out pretty good. It was we had a few difficulties, but we got there. All right, let's go install this over on the drill press and just see how everything works together. Look, there's even an arrow after we cleaned it that shows which way it goes. Just looking at this, I could have made that shoulder longer. It's all right. We matched the original. Okay, let's see what happens when we tighten it. Uh-oh. Houston, we have a problem. As soon as I shut the camera off, I realized what was wrong. Okay, so here's how we're going to fix this. If you install it the right direction, it'll make a big difference. But I did have a spacer. I'm going to put a spacer up here. That way we get full contact. Just make sure that, yeah. Okay, again, sorry about the bad lighting, guys. It's a dark corner over here. Okay, so I've got the arrow pointing that way, and it actually says vise that way. All right, so watch what happens when we tighten down our clamp here. You see that? Same problem that Prozo had. All right, so it's lifting the vise instead of pushing it down. All right, I'm going to turn this around. Okay, I got the clamp block turned around. Let's tighten it down and watch what happens. There we go. Now it's not, actually it is pressing down pretty good. That's probably all it needs. I mean, there's a little bit of float on that one, but that one's tight. Okay, arrow is wrong. All right. Well, good. Well, let's drill something. This was our sacrificial block that we have over at the mill. So let's sacrifice it some more. I think it's easier if you, well, let's see. Okay, I gotta figure out how you work this thing. All right, there we go. And since we already got holes on that side, let's continue with that side. All right, so we're using the grooves that are already in here, which is a nice feature. All right, and let's just say we're going to drill right there. We don't have anything marked, but let's make sure our table's tight also. Okay, here we go. It's a 27/64 split point bit. No pilot hole, going straight in. My table wants to rotate. Okay. Did we make it all the way through? No, we hit the drill stop. There we go. Didn't know I had that stop set from the previous project. All right. Oh, there we are. We're through. It works. Okay, we're gonna call that done. Hey guys, thanks a lot. Yeah, that's gonna make that drill press a lot more convenient to use. It doesn't get a lot of use. It's kind of tucked away in the corner over there, and it's not bolted down either or leveled. So I've still got to do some rearranging over in that area to make things a little more user friendly. Most of the time I end up just going over to the mill to drill stuff. And the little benchtop drill press, it gets a lot of use, although right now it's a clutter city around it. Okay, all right, thanks guys. We will see you on the next one. Bye now.